So all right, guys. So sorry for the delay. So first thing, regards to the web portal. So no voice, no audio.
I'm getting you.
Okay.
Can hear you.
Yeah, that's fine.
Okay. Yeah. So with respect to the web portal, you have received an email from my side. Okay. So he's not in mute. So you have received an email from me. You basically have to copy that link and just place it here. Okay. So what it does is it's gonna ask you for username and password. Okay. So why is it working is because I'm already logged in. So I'll show you from step 1. I'm just gonna log out from here. Okay. So I'm showing it from step number 1. That's the link which you have over on email. Just put up on your browser, and those guys who wanna get this link, what I do is I'll just put up on our group, okay, the CCNP group. So it's already in the email, but I just giving you the updated link. So once you get this, you are able to see something called as login. Click over there. It's asking you username and password. So once again, go back to the portal. So to demonstrate this, I have created a test user. Okay, so I'm gonna place my user ID and the password, which is mentioned here. And just place it here. Login. Okay, so over here, the good thing is it didn't ask you for a password, but there is a second layer of authentication. So basically, you will not be able to see the content over here. So it will ask you for a second layer of password, which is something again in your email, which from my side. So that's this password. So you have to take the second password and enter over there. Let me show you, or let me explore this. You can see there are some demo videos, and these are the videos that's only for the enrolled student. So you will see all of these would be secured one. So you need to have the password and you need to unlock them. So if you click to the second one, the PDF, I'm going to show you how do you download PDF. So once again, since I have already bypassing the second layer of authentication, in your case you will see a prompt to enter the password. So once you enter that, it's gonna there for like next 24 to 48 hours. You don't have to keep doing that, right? So that's the second layer of authentication, and this is the password which is on your email. So how do you go download any PDFs? So basically, videos are not downloadable. You will not be able to download the videos. Yes, you can play them. You can get the full screen size. So you can do the way you want. You can play it around. Okay, you can also use your mobile and you can play it around. When coming to the PDF, since we all want the PDF on our dual monitor, might be I'm doing a lab where I have to see the task and then execute. So basically, we have 2 3 monitors, right? And it's better that we have PDF in a printed format. Maybe you want to print the PDFs, or you want to keep this in a PDF. Might be you do not like the hold the whole console. So this is for someone who can actually view it directly on the web portal. But let's say you have some issue with this, then you just click on this logo. If once you click that, it's gonna go to the download page. Okay, and from there you can download this. So once you go over here, there's an option to download, and once you download, it's asking you for some uh, username and password, and this is a mandatory step. So you need to be having the LinkedIn profile. If you don't have, just create a dummy profile, and it's gonna let you download. Okay, it's a single step download. So that's how we download, and that's how we explore the web portal. Now regarding to the lab setup, as you know, a lot of or most of you have got my download links. So I believe you download them and then come back to me, and then I'll patch you with the lab trainer. Okay. So since we are also starting another batch for network automation, so we have a lot of student, and there are a lot of student engaging the lab trainer, and a lab trainer can set up like 5 to 7 students in a day. The only reason is because the student come with a very slow running laptops, or sometimes they have their office laptop, sometimes a lot of restrictions. So each student might get some like 45 1 hour to set up a lab on their system, right? So that's the only reason why there's so much or there's a little delay over here. But need not to worry, the next few classes are theory topics. As you know, it's all about bridging that we are trying to do now, CCNA to CCNP. So we are not starting lab so far. Okay, one second. So that's about the lab, which will be done in a span of some time. So just don't rush. You all have the lab trainer number. Engage him and get the availability. Might be he give you a fixed time for the next day, right? And then at that particular time, just contact and get the lab setup done. Fine. So that's lab. That's the web portal. So what about the topic for the day? So where did we stop previously? So I guess I was explaining the different network components like Cisco switch, the details of Cisco switches, the latest devices which have the supervisors, the chassis, the line cards. Okay, and then I was talking about the 3 planes over here. So what is actually these 3 planes on a Cisco box? To make it more easier, I'll show you few boxes. Okay. So this is a software which is free to use, free to download. You can download it yourself. It's called as Cisco CX catalog. and it has a lot of devices, lot of device information. So for example, when click on switch, I have the catalyst switches, the MDS switches, the ME series Nexus. If I go back and click on routers, I have ASRs, I have ISR, I have NCS, I have the Cisco carrier router systems, and so on. So on. Few of the devices. Now, what can we do on this software is, if I go to the router and let's say I go on one of the ASR boxes, let's go with 9K series of ASR. Okay, if I just open up 9010, so you can see the 3D view of this box. You can just rotate them. Okay, you can just play around, you can just see what they consist of. So you can see these are the cables for your external powers. So these are those exhaust outlet. You can also check it in this way. Okay, zoom in, zoom out, the way you want. See, the each individual components can be easily demonstrated. You can see what is this device consisting of. Okay, so what is these things? These are PSU, power supply unit. These are hot swappable. That means you can just uh, can unplug. You can just take one of the PSU out. You can plug. You can just take the faulty PSU out and plug a new one, right? So these are hot swappable power supplies. And over here, you have line cards, you have supervisors. Okay, so you just need to like click on them. So it's a CFP optics. If you click here, it's gonna be integrated service modules. If you click over here, it's gonna be the line card, 8 port 100 gigab Ethernet modules. If you click on the next one, it's RSP 8080. That's nothing but your supervisor. There's one more processor or a supervisor here, RSP 440. You have a line card with 40 gigs of Ethernet line card. You have modular line card, and then you have again a line card. So basically line cards with different Ethernet technology. You can also plug out them. So if for example, if you want to take them out, you just have to like remove them. Okay, so they're gonna show you how this unit looks like. So it's basically made up of the chips, the motherboards, okay, the circuits. So you get some free time and just try to go through the different devices, just from the knowledge point of view. Okay, so this is the back end of this. Now let's say I just plug it back and I take out the supervisor. Okay, the supervisor. So what does this consist of? So you have your uh, couple of ports here. Okay, management LAN, the console, the auxiliary ports, service LAN. So you don't see any data interfaces here, right? So So they are supervisors. They are called as control planes. I'm going to tell you what are control planes and what is data planes. Okay. So where is your actual traffic moving on? So how is traffic within these devices move on? Okay. So let's see, let's open up one of the line card in that case. Okay, so I'll just take some other line card where we see the Ethernet. Let's take this one, the Giga Ethernet. Okay, so you can see these are the line cards. Okay, and what are these line cards? They are your 10 gig uh, line cards. They are 10 gigs line cards. So you have 24 into 10 gigs. So this is a Ethernet line card. So let me show you that 40 gig line card, which is consisting of the Ethernet technologies. So this is so basically one box can have like optic line card, the Ethernet line card with gig interface. Okay, so you see these are all the Ethernet technologies. So that's the beauty of the software. You can explore a lot of things which you normally don't see in a online classes. You need a physical device where you want to open them and just explore, which is really not possible even in the institute, because they don't give you these devices. They are very costly devices. So what Cisco has made it, they have just created this kind of softwares where you can at least see what is within them, and you just can get a kind of understanding how these devices work. Now that was what the device which I showed you was a latest piece of technology. Now let me show you one of the older devices. Okay, that is ASR 900. So if I open up this is just a simple box. There's no control plane, there's no separate control plane, there is no separate data plane. So basically on one chip you have all the three planes. You have all your control plane, all the three planes, all the control management and data planes. Okay, so if you just see from the menu point of view, you will not see much of details here. You just have only front view, that's all. And if you just try to zoom, you see the Ethernet line cards. I don't say it a line card because we have only one embedded line cards. We cannot remove them, neither we can extend, or we cannot even do anything, right? So there's a uplinks, dedicated uplinks on your left hand side. You have the Ethernet line cards. You have some RJ45 where you can set for monitoring, which it reads out to be alarm. So let's see what exactly is that. Alarm interface. Might be you want to configure to some uh, monitoring tool to receive. Okay. So if you see, if you click over here, they're also gonna show you the diameters of those units. So it says approximately dot 2 inches to dot, or that's dot 4 centimeters. It's giving you rough idea how big this devices would be, how this would look like in real. Okay, these are the optic fiber SFP. So you can insert your optical fibers on these boxes. There is no hot swappable concept in this kind of devices. So if something goes down, even if one interface goes down, you basically have to give out the whole box to the Cisco and get the RMA created or get the new box. Okay, there is no concept of hot swappable, like unlike we saw in the previous example. So you have only one fan unit, okay, which is embedded within the box, so you cannot remove them. So this is a difference between a traditional box and the latest box. The latest box are all coming with the unplug options where you can swap any faulty devices without sending back the entire unit. Okay, and these are some older boxes, which are older, all the legacy boxes, which we keep in the access layer to the distribution layers. Okay. Now coming back to the three planes, I gave you two examples. The one example was ASR 9K, which had something called as supervisor. It had separate data line cards, right? And also I showed you one more example, which was ASR 900, a basic unit, which has everything within one single unit. That was all your three planes, your control planes, your data planes, plus your management plane on a single box. Now, what are these planes? Okay, we need to understand what are these things. So let me tell you in this way. Uh, let's say I have a Cisco box, a Cisco router. Let's take it that way. I have one network, any sorts of network. Let's say network one, and I have network two. Okay, now let's say the packet is just traveling in this way. So what would the packet, or how the packet would process within them, right? So let's talk from the latest hardware point of view, where we have three separate planes. One is control plane, when the data planes, and the management plane. Okay, the three different planes. So when I receive something, okay, when I receive something, and if it's just transmitting, or it's transiting only, there is no uh, self processing required. A traffic just comes and just passes over on this router. Okay, now that's happening on the data plane. So I can say it's passing through the box. Okay, that's called as data planes. What is control plane then? Control plane is something when you send a special packet and it needs some lookup in the sense a routing lookup. It could be a ping with dead TTL, so it will go undergo for lookup. Might be the packets are for a ARP lookup. So basically the data plane is not capable of handling such packet. So what data plane does is, since even though it's receiving it, it's gonna push it to the control plane, and control plane act as your brain of the box. It's gonna check this table and it's gonna say, to reach to the network 2, go out of your interface 0/1. And that is what we have over here, control plane, which is acting as brain. Now what is management? Management is all your telnet traffic, SSH traffic, console traffic. Okay, so all these are your management traffic. Okay, let me write it in this way: telnet, SSH. So do you think management is a control or a data plane? Okay, so I would say that to conclude if management is control or data, you need to check it from the device point of view. Okay, if the traffic is originating within itself, okay, within itself, if the device is originating within itself, then the management will be part of the control. But if it was passing through, then the management will be part of the data plane. So that's something which we have to see from the device point of view. In the case of the legacy boxes, all the three planes are embedded in one single chip. Okay, you have your data planes, you have your control planes, and you have management plane. And you will see the problem with these kind of boxes are that even a fluctuation on the CPU or on the resources, you will see the packets start dropping, right? The packets start dropping. The reason is all the three planes are in one single unit. There is no distinguish or there's no separate planes. So if there is lot of data, it's gonna impact the control plane. If there is lot of management traffic, it's gonna impact the other ones. So basically the more traffic, they are all three gonna get impacted, and you will see the packet is getting dropped. Okay, now what about the latest boxes? The latest box where we keep the three planes separate, like we have separate control, we have separate data plane, and we have separate management plane. But management can be part of either data or part of control, but we keep it as different because it only consists of your user management traffic only. Okay, so in this case what happens is your control plane act as a brain for the whole decision maker. If something comes from one network towards another network, your control plane is not even involved, so that means nothing is gonna impact it. It's only your data plane that's gonna push the traffic. Okay, so data plane is good. It is not uh, it don't have to rely on someone's decision. Okay, now let's say there is something which needs lookup, like your ping packet with dead TTLs, might be your OSPF packets or BGP packets or a ARP request, where the data plane cannot handle that traffic, because data plane is considered to just push the packet. You get something, the router is going to push it. It's not going to do the lookup, unnecessary lookup, and just create a lot of process or create a lot of overhead on the box. You get something, the data plane is sending it out. So only that traffic which is requiring lookup will be sent to the control plane, and the control plane will check the tables, and it's going to say to go to that destination network, go out of this network. Okay, so the planes are kept separated so that the planes don't get so that one due to one plane the other planes don't behave abnormally. That's the main concept of separating these three planes. If you talk from the SDN point of view, software defined network, we are doing the same thing actually. So we when we talk about SD access, SD WAN, or ACI, what are actually these things doing? Basically they are segmenting those planes. They are separating your control planes, that you have a separate data planes, and then you have the management plane. So basically they have their own controllers. The controllers are nothing but controlling the control planes. Okay, so you can control all the control planes. They becomes the brain of your organization. And underneath or on underlay, you have your devices cabled up, and they do the just data plane transfer. So all your control plane is being handled by these technologies: SDA, SD-WAN, ACI. Okay, and what we call them, we call them as overlay. And beneath them, the 12 devices, we call them as underlay. And we have these physical devices on premises, on a data center, where they are structured with cables, all those things. They are only making the data plane usage, that's all. Okay, so the concept of the software defined is just to segment, or just to take that control plane out of the boxes. You don't want the boxes to do the decision maker and then cause impact on the packet processing. Okay, the whole intention is to keep as much as free spaces. You get some packet, the router is sending or forwarding it to someone else. Okay, you're not gonna keep it with you. Might be the next packet comes, it's going to the queue buffer and then getting dropped up, right? So we don't want packet loss. We need a good 100% successful rate. That's why we make use of these SDN concept to do control the control plane. And in case of the organization where you do not have these SDN still, then these are the three different planes that we just discussed. So in case of a single box, a single standalone unit, all the three planes will be embedded within one single unit. Whereas all your latest boxes, they have the separate planes. Control for controlling, you have your supervisors. So we something right like this. Let me show you. So if you see here, I mentioned there are a couple of line cards. So basically, on this box, line card is doing only the forwarding of the packets. Soup engines are when you need the lookups, okay, and they act as the controlling. So you're keeping them all separate so that due to one uh, because of one intensive workload, the whole box don't get suffered, right? So just you're keeping it separate. So whenever uh, the right packets come in, or you need to just process it, it will just go and do its job accordingly. Okay, so I've just included one more document which I just explained. It's something which is written over here. So when you get some simple packet, or when the traffic is like from a network to another network, so this device XYZ is just this transit. So in such cases, it's just flowing through the data plane. Okay, your control plane is not impacted. So that's just a forwarding table. But in the case of the packets which needs lookup, okay, let's say when the packets needs to see how to reach the destination, it can be like OSPF, it can be your uh, let me keep this over here. So you can see my screen. So the packets which goes from data to control is called as special packet. Okay, the packet which cannot be forwarded by the data plane immediately and have to be sent to the control plane. Some example of such special packets are when your packets are destined for a another IP address, something like uh, a different networks, or in the some case when the lookup has to be checked, the routing information has to be checked to see how to reach the destination packet or destination network, right? Or sometimes like when you have the traffic for OSPF, EIGRP, BGP, when let's say your packet are originating within your router and they are part of OSPF or any sorts of protocol. So in that case, it originates from the control plane. Sometimes when you have packet with some option set in the IP header, if you remember, the IP header has lot of components. Okay, sometimes DSCP, you have some flags. So some packets with some header cannot be directly processed by data plane. A data plane cannot make the decision, so it will automatically forward to the control plane. Control plane will see what is the content of that, and then accordingly it will send back to the data plane and it will be forwarded. And some packet, when the packet with a expired TTL, time to live. What is TTL? TTL is time to live. So this component will be set up with some numbers. The maximum it can have is 255. So what happens is, uh, so basically what TTL is actually, so let's say when I have a set of routers placed in one path. Okay, let's say one of the packet with TTL 1 is just hitting the first box. So once it hits the TTL over here, the TTL is gonna get decremented by -1. So basically this is gonna be 0 now. So if you get a TTL 0, it's gonna take back a message saying that this is the host, or whatever the host name it is, like 192.168.1.1, and then the packet is gonna get dropped. Your packet what you sent is not no longer gonna get to the next box. Okay, so you just get the information that your packet reached to this device and then it got dropped, and there is where you start troubleshooting. Now you can log into this box and you see if there is a uh, routing enabled to this device, or some is there something missing or something, you can troubleshoot. Now let's say you are sending a TTL with a 10 number. So what happens is every time it get decremented by 1. So you have TTL 9, you get TTL 8, you have TTL 7, you have TTL 6. So every time you're gonna get a response back, and that's how hop by hop you're gonna collect the information. So let's say this is 1.1. So once it is over here, the TTL get decremented and it's gonna take the response back saying like this. Okay, so this is just a rough example. So basically I'm trying to give you a demonstration of traceroute, how traceroute works. Okay, but yes, we have this in topic where I'll cover up from the uh, syllabus point of view. Okay, so that's something which will come in the CCNP. So as of now we are just trying to bridge CCNA with CCNP. So we are just trying to see all the different aspects of the router and the switches. Okay, and one more thing over here that I have missed is uh, so faster delivery of the packets. Okay, so within control plane on the high end boxes, you might have seen the tables like tcam, cam table, right? The routing information table. So basically the packets which goes to the control plane are actually making use of these technologies. Okay, they are using this technology, and these technology are meant for fastness. They are gonna give a faster output. But what are they exactly? So that's what I've mentioned here. So basically you might have heard something called as ASIC. Okay, ASIC is nothing but it's application specific integrated circuit. So where does this is seen? This is integrated on your hardware chip. Okay, so if you have the hardware, the Cisco box on your motherboard, you have these ASCII integrated chips. So these chips is capable of your faster delivery of your MAC address lookup, router table, access list. So basically these are the information that's stored inside this ASIC. And where are these ASIC? These are in your control planes. That's why when you send something from data plane to control plane has to be faster. If it takes a lot of time, then basically you're losing or you're creating the latency yourself, right? So these are the technology that's making the processing faster in the control plane. So what are these cam tables or tcam tables? So basically cam is nothing but content addressable memory, and tcam is ternary content address memory. So these are like your the advanced technologies which is doing the high end processing. The cam table is used for storing the layer 2 information. So what is cam table gonna help us? So basically it's gonna keep the MAC address sources. Okay, source MAC address. It's gonna tell you which interface the MAC address were learned, interface learning, to which is that MAC address belongs to. So basically your camp table is a high or a faster version of your MAC address table. Okay, so when any processing happens, it first checks the cam table, because cam tables are much faster. Okay, and it has all the records within it. So it has source MAC address, it has uh, the interface, the MAC is being learned, it's having the information of the VLAN that's associated with MAC. Okay, that's the cam table. Now what is tcam? Tcam on other side, okay, on other side, the tcam is used for the high layer information like access list, QoS, routing table. So I'm going to write over here QoS, ACL, and routing table. So things are getting processed faster, right? In a control plane, you're sending a lot of data. So you might be wondering what exactly happens inside control plane. it's happening, it's processing, it's looking for the destination. But who is helping you to achieve that fastness? It's your integrated applications or integrated circuits, right? That's ASIC. And ASIC consists of like your cam tables, tcam tables. So basically cam is for layer 2 lookup, tcam is for your all like ACLs or routing tables or QoS. Okay, so this is the internal part of these control planes. So if you see talk from the uh, sorry, so from the device point of view, so the ASIC will be integrated on the circuit board. Okay, so basically to give you the best processing. Okay, what type of switches do we have in the industry? So we have iOS switches, we have Nexus switches, which is kept in the data centers. We have modular switches. We have the fixed switches. Okay, they are used in industry like where the temperatures, all those things have to be uh, certain about. We have stackable switch. Okay, in the case of stackable switch, we just bind multiple stackable switches so that we get a single control plane with multiple data planes. Now things are going in depth. Okay, this is how the CCNP is. So we are still bridging, but we are bridging in very depth level. Okay, not just from the CCNA point of view. So you are gonna see all these topic. Uh, might be in CCNA also. In CCNA also we have topics like stackable, VSS, all those things. So let me tell you some terminologies. So when do we call a standalone switch? Okay, so someone calling as a standalone switch is when you have a single piece of boxes. It can be any box. It can be 3750. It can be just 2750. Okay, it can be those big boxes with the 6500. It can be 3750. If you have them cables in a single mode, they are called as standalone. What are the drawbacks of this? The drawback of this is, so on these boxes they have a single plane. That's all the single plane consists of all the three, like control plane, data plane, and the management plane. What is the problem with this? So you still have the control plane separate. Okay, and you have a data plane and management plane, but you need something like, you want to aggregate your traffic. That means your incoming flow of traffics are more. Your single box cannot uh, accumulate those processing. The packet level is now very high. So what would you do in such scenario? You would bind one more box with the similar hardware. So for stackable, the main thing is they must be a similar hardware. You cannot have one 3750 and other one something like 1750, something like, you cannot have them. There should be a single piece of hardware, and some devices have this capabilities and some do not have. So you should read the data sheet. So if you type Cisco 3750 data sheet on Google, you will get the entire data sheet where it will say that these switches can be used as stackable. Also, they can be used as a standalone. So in case your requirement is for standalone, go with standalone. But in case you want to stack, then this is the way we stack. So we have three boxes or four boxes. These are some special cables. These are not the console cable, these are the stackable cables, and we connect in this pattern. So why do we do this is, even if one box goes down, we still have the redundancy. We still have backup switches which is serving the traffic. And the good thing is, all the four will have one single control plane now. Okay, So out of the 4 boxes, one box is gonna be considered as a master, which act as a control plane. And the rest of the boxes, let's say these all are 16 ports, 16, 16, 16. So you are gonna get 16 into 4 data planes, active data planes. That means all these 16 into 4 are gonna be active. That means we can connect to multiple hosts, one single control. Okay, what happens if you keep them standalone? There will be 4 instances of control plane. There would be there would be 4 different instances of data plane, right? So basically, to get the high potential, in case you need the device solution to have uh, to process the traffic, so you have to make use of the stack. Okay, so now this stack, the term stack, we use in the uh, access layer point of view, in access layer, in the and the distribution layer, we make use of stack. But when we go to the core layer, we have the same concept but with a different terminology. It's called as VSS, switch virtual switch. Okay, so what does VSS do? So basically it does the same thing. You have 2 boxes, you have to connect a cable between these two, and this cable will be called as VSL, virtual switch link. This will be A and this will be B. They will have one single control plane. So one box act as a control plane, and rest of the ports act as active ports. So let's say this is 48 port and this is 48 port. So you're gonna get 2 into 48 active ports. So this is how we do aggregation, packet aggregation. This is when we are dealing with lot of packets. If you're just talking about few packets, you don't have to do all these things. You can make use of single box and keep it as a standalone box. Okay, there are a lot of aggregation concepts nowadays. For examples, uh, like uh, like I said about, from the hardware point of view, when you combine multiple hardwares, so in a access and distribution, we call the term as stack. When we do the same thing in a core layer, we call it as VSS. A similar way, we can also aggregate the interface. Let's say I have one interface between them, but this interface is not capable of handling all the in and outgoing packets. So what you do is you start adding more interface and you start bundling them. Now that concept is called as ether channel. Okay, now similar way, in case of the data center nexus, you have something called VPC. You have your 5K over on the top, you have your 2Ks beneath. Okay, something like this, and you're just creating the VPC1, VPC2. Okay, so these are all aggregation topics. And why do we use this? Because I'm not happy with my single box. I think my single box cannot handle so much of traffic. I need multiple devices doing the same job. Okay, so I'm just trying to combine the things and giving the high throughput. There's one more reason for doing all those things, that is your layer 2 issues. Okay, so in the case of layer 2 issue, or in the case of layer 2 loopings, to avoid layer 2 loopings, we make use of a technology called as spanning tree protocol. So basically what spanning tree protocol does is, so let's say I have a switch A and switch B. Let's say they are a standalone boxes and they are connected in a single cable. And I feel they're not giving me the good throughput. So in future or in the upcoming days, I bring one more cable. Now what happens is automatically the looping happens. So what is looping is, so basically if I'm sending some Ethernet frames, the frames will be pushed to both of the interfaces, because switch does broadcasting. So what happens, the traffic goes from this, the traffic is going over here, it comes to this, it's gonna do the reflooding back, okay, on all the active, and same thing happens over here, it's gonna reflood. So basically one layer of the traffic is just circulating in this path. Now what happens with this is, when they are going port by port, the MAC address tables are getting impacted, because the same traffic is hitting the interface, gets changed to different interface, the MAC address table gets updated, goes back to this, the MAC address table once again. So basically your overhead on these boxes are increasing. You're able to see the MAC address table inconsistency. You will see a lot of duplicate MAC address in such scenarios, and basically the device will now start dropping the actual required traffic due to this looping. So to avoid this scenario, I only have one option. Instead of two cables, I just have to connect one cable. Now I'm not happy with one cable, so what is the next method? The next method is, I can still bring the second cable, but I'll get this concept that's called as ether channel. So when I do a ether channel concept, so logically what happens is, the two boxes, okay, and the two interface, now they start looking logically as a single link. Okay, so the STP, the spanning tree, now get confuses. Now it thinks that, okay, so this is just a one single cable between two devices, so I just have to run one instance of the STP, I don't have to consider it to be two different things. So basically STP is not gonna block the second interface. Okay, so that's how we bundle them, we take care of the STP issues. Okay, and that's how we give the throughput. So basically these are all the aggregation topic, and depends from the point of uh, implementation. If you go with data centers, you call VPC, you have stack, you have VSS. A similar way on a firewalls, Cisco firewalls, you might have heard about context, right? So that's again doing the same thing. uh, Basically we also have virtual. In case of virtual, we call it as VRF, routing VRFs, right? So we are separating the context, we are separating so that we can uh, we don't bring overload on it on uh, other devices due to one reason. So basically we are aggregating the whole technology so that we have a better network. Okay, so this was regards to the switches. We have iOS, Nexus 2K, 5K, 7K and 9K. So there's a typo here, so this should be 7K. Okay, and these are like the devices that we keep in the data centers. Modular switches, the examples are 6500, 6800, 9400. Okay, so you have, so these are having the three different control, the three different planes. Okay, control separate data plane, and a management plane. As I told you, if you see from the device point of view, you can just say if it's part of control or it's part of data. These are one which are kept in inside industries. Okay, where the temperature has to be a main concern. Or let's say you have a outdoor routers where the temperature is might be in minus degrees or very extreme conditions. So basically they are very durable, they're very high potential devices. Then the stackable switches. Okay, so what is basic difference between a switch and a router? Because I'm heading towards router, so if I give you an just a comparison between switch and router, so let me tell you, switches are used to connect multiple end host devices, right? So multiple end host devices, that can be a IP printer, scanner, computers like laptops, access point, servers, any end devices. They are used to connect to the switches. How do switches work? Switches work on a MAC address table. So we basically call it as switching technology. The packets that we see within the switch, we normally call it as frames. And from the OSI layer point of view, they work on OSI layer 2, okay, in a data link layers. So what is data link layer consist of? The data link layer consists of two sub modules. One is called as MAC, and second one is called as LLC, logical link control, and MAC address table, or a MAC address control. Okay, so this is a little bit on switches. Now what is router on other hand? So router is something which connects two different networks. So let's say I have a network of 192.168, and I have a network of 172 something, and I have this router in intermediate. So basically, if I want to connect from network 1 to network 2, I need a router, right? So I can say they interconnect different networks. Okay. So we talk about IP address. So I'm gonna say that they are they work on IP address, not MAC address. They're gonna work on IP address. Where are these IP address? What are they? Where are they stored? They're stored in a routing information base or a routing table. Okay. Whereas in switch we have MAC address table, where all the MAC address, learned MAC address will be stored in MAC address table. Okay, which OSI layer does router work? It run on, or it works on layer 3, which is called as network layers. Okay, so the basic job of network layer is uh, to give the best path to reach the destination. So basically, what happens is, so let's say this is your router, okay, and let's say your packet is over here. So this router has couple of different routers connected. Okay, they might look as same, like same two hops, two hops, and two hops, but the issue could be with respective to the interface and the cable technology. Might be the cable used here is a Ethernet cable, might be cable used here is a fast Ethernet cable, and similar way cable used here is Giga Ethernet. Now when you have a same equal distance, the packet or which path it would take, basically to prefer this path because of a better distance, right? So how it exactly work is, when you have a better distance, routing, what does it do is, it start converting those technology to some standard values, like it's called as cost. In case of gig, what happens, the cost will be very less. In case of fast Ethernet, cost will be like 10. Like I'm just giving you example. In case of Ethernet, the cost is gonna be 100. Now it's something like your cost value. Now let's say you are boarding a metro and you want to travel some source to destination. You have three different means to travel, like you have a metro, you have your own self driven cars, might be you have flight. Okay, let's say metro is charging $2, okay, whereas self driven car 10, whereas flight 100. So which one are you gonna prefer? You're basically gonna prefer the shortest cost, that's gonna uh, 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 that you are gonna spend, right? So similar way, what router does is, it gives you the shortest path to reach the destination. Okay, it's giving you the shortest path, even though there are three, it's gonna see which is the shortest. Second, it's gonna connect two different networks. So on this side I have 4.4.4, on this side I have 1.1.1.1. So basically router is interconnecting. That's the basic uh, definition of a router, and it's a layer 3. Okay, the reason why I wanted to clear this is because when I go to router, you guys might think what is a difference between router and switch. So that's why I made use of this. Okay, this is a router. They will look very similar to switch, but they work very different than switch. Okay, so in the case of router has 4 building blocks. So basically, when the traffic hits to an interface, we call it as input port. It goes to the switching fabric, it goes to the routing processor, and then it finally goes away. So basically, this is inbound traffic, this is outgoing traffic, and then you have the processing happening. So basically, what is happening is you have multiple interfaces like gig 0/1, gig 0/1, sorry, 0/0, 0/1, 0/2, 0/3. Similar way over here, maybe you have 0/4, 0/5, and so on. So inside a router, basically, what it happens is it receives the packet, and then it goes to the switching fabric. If it just if it's something which just it's just transmitting, then it's not gonna send to the routing processor. Routing processor is something which is gonna maintain the forwarding table, like it's gonna have the routing base information, or like a lookup, a concept that we discussed in the case of switching. In the case of switching, I discussed few minutes back. Now this is in the case of router, what happens within a router. Okay, so in case of router, this is the switching fabric which will do all the traffic. Okay, all the traffic flow. But if there is some lookup involved, then it will be pushed to the RP, that is routing processor. Routing processor will send back that to the switching fabric, and then you have your all outbound ports connected to the switching fabric directly. So routing processor is not gonna directly connect with any of the outgoing ports. It's just a uh, it's just part within the router. It's only be involved when the switching fabric sends some packet for a lookup, like a routing table or something, and then it's gonna check and it's gonna push it. I have some given some brief information about both of them. So once a router receives a packet on the input, okay, so basically that's from the input port of view. And what happens is, when the packet was read by the router, after performing the longest prefix match, it was found that packet should be forwarded to the next network through the third output port. Okay, and there is where the switching fabric happens. Now once again, this is little bit tricky thing. Okay, and I assume you might be knowing about this already. So how is routing decision happening? In case of routers, how is routing decision happening? There are 3 steps. First step, longest prefix match. Second step, administrative distance. And the third is your cost or metric, right? What is longest prefix? Let's say I have a router, okay? And let's say a traffic just comes to this router. Now the traffic which comes to the router, and might be router has its own routing table where it has something for 1.1.1./30, and it has 1.1.1 for /24. Same network but different subnet mask. This says the destination should be to this, but this says the destination should be to this. Okay, now whatever packets just come within to the router, now the first thing, the decision making is based on longest prefix match. Who is longest here? So it's basically /30 is longest here. So basically what router will consider this as a best decision. The only reason is because /30, okay, which is a longest prefix match. It's not going to consider 24. Okay, so that's the decision maker that router is gonna do. So when you have something, some scenarios coming in like this, then that's your switching fabric, it's gonna take care of it. Okay, your switching fabric will solve this kind of issues. It's not gonna include, or it's not gonna involve routing processor. When is routing processing involved? Routing processing is involved when you go towards the second and the third step, that is administrative distance and the cost. And what is that? Now let's say the same diagram, okay, and I write it in this way. I have a router here and I have a router here. So let's say over here I am running EIGRP, and over here I am running OSPF. Now some packets comes to me, okay, like 1.1.1.1/24. Now the router has two ways to reach the destination 2.2.2. Now what do I say? Administrative distance. So every protocol have their own administrative distance. In case of EIGRP, it's 90 and OSPF 110, right? So basically, it's gonna consider EIGRP and it's gonna take that path. So who is gonna make that decision? That's your routing processor. So packet comes to switching fabric. Switching fabric is gonna send to routing processor. Routing processor has the entire routing information. It knows that this is the protocol with 90 AD value, or this is the path, or this is the protocol with so and so, and it's gonna say let's prefer EIGRP because of the shortest or the lowest AD value. That's one scenario. Similar way in the case of cost. When do I get the cost concern? So let's say I have a similar diagram. I have 1.1.1 looking forward to 2.2.2. I have OSPF. I also have OSPF. But these are on different costs. They are like Ethernet technologies, and these are like Giga Ethernet technologies. So the cost here would be like 10, whereas the cost there would be like 100. So in such scenarios also, switching fabric will not make the decision. It will send to the routing processor. Routing processor has the uh, routing information uh, within it, so it's gonna see these things and it's gonna make the decision. So that's from the router internal processing point of view. As I told, three ways of routing makes the decision: longest prefix match, administrative distance, cost metric. Okay, and yes, this is just one more component of your LAN segment, which is called as Cisco ASIC firewall. If you see here, I have kept one of the instance of ASA box. Okay, that's because it's just a bonus topic. Might be I'll give one class on the basic on ASA. In case if you know that, we can ignore that. In case if you wanna know little bit on the firewall side, then I'll take one or two classes where I'll show you the policies. I'll show you what are the different zones that we have in the ASA. Okay, that's just a bonus topic, not a part of enterprise. Okay, so once again, from the packet level of view, since we are talking about the packet level of a switch router, now what is the packet level in the case of the firewalls, ASA firewall? So you receive something, it's gonna see the existing connection, it's gonna see if you already have an connection or not, and then depending upon that it's gonna make decision. So if you have existing connection, it's gonna send directly to inspection engine. If it doesn't have a connection, it's gonna send for ACL check, then it's gonna see the NAT check, and then it's gonna go to inspection engine, where it's gonna keep a record of this entry, and then it's gonna send it to the NAT header. That's nothing but it's gonna send towards the outgoing interface. It's gonna send to the egress interface. It's gonna see the route lookup to see which destination physical interface that it has to send the packet. It's gonna see the L2 header, if the rightful uh, L2 information is associated or not, and then it will finally go out. Okay, so in the case of ASA firewall, it's different steps that we follow. If a traffic is just flowing across over here from the incoming and the outgoing, so these are the steps. We have incoming traffic, which will first see if the connection are already present or this is a first time initiated connection, and basis on that you have the flow chart. How does a firewall work? So basically, if you plug a firewall and if you plug a switch or a router, they work in two different way. By default, your router and switch are allowing all the traffic, whereas by default in case of firewall, they are denying all the traffic. So you send some traffic, they're gonna get denied. So how do you allow them? You allow them by writing access lists. So you are gonna say that if so and so packet comes, allow it. If something comes out of that line, they're gonna get denied. Okay, so firewall act as like a barrier in your network. And where do we keep firewall? We can keep either in the core or we can also keep in the distribution layer. So let's say I draw a 3-tier architecture. So this is my core, this is my distribution, and let's say I have some access layer switches. So where are firewalls kept? Firewalls can be kept somewhere in the distribution layer, like something like this. Okay. Firewall can also be kept over here, which terminates to ISP. Now the two firewalls are doing two different work. The ASA firewall that is kept on the ISP is for your incoming and outgoing internet traffic. If you are getting a traffic from some strange IPs, you are gonna deny them. Okay, something like if you heard about DDoS or DOS attack. So what are these things? So basically, someone is continuously sending a lot of ping attacks. So what your ASA firewall can do is it can immediately stop them, because by default they are gonna deny, right? So all the traffic is gonna deny. But what happens if you have the core router acting as the topmost layer? Now in this case, if you receive something, the core is gonna start processing it. It's gonna see if something is there, and then if it doesn't find, then it's gonna drop them. If it finds, it's gonna push it inside. But what is attacker gonna do? Attacker just wanna bring this down by sending like more than 10 lakhs of traffic in 1 second. So what happens? The processing, the RP of this or the switching fabric will start spending their time spending their time on processing the packet for route lookup, and gradually the router is down. Okay, if you keep this router in the first point. So to avoid such thing, we keep ASA firewall, because ASA firewall will not process. It will immediately block in the ingress level itself. So your traffic, once it hits here, it's not going to process it. It will immediately drop it. That's the benefit of keeping ASA here. When do I say we need ASA in the distribution? Now, let's say I have multiple teams sitting in my office. I have IT team, I have marketing team, I have sales team, I have servers team, I have network team, I have load balancer team. Now let's say there are a couple of servers, okay, and in normal scenarios, as you know, router and switches are gonna do allow, and there could be some uh, ROG devices, ROGUE, okay, who is causing a lot of uh, L2 attacks. I can say as L2 attacks, ARP attacks, MAC address attacks, CDP attacks, okay? Or someone just trying to initiate a lot of pings and trying to disturb the health of a server. So what I can do is I can bring ASA firewall here, and I can just point all my L3 gateways to ASA firewall. So if any traffic initiate, it directly goes to the ASA firewall. And as you know, ASA is straight away gonna drop it. It's not gonna process it. Okay. So that's where ASA is placed. And it's a firewall. Firewall are used as security appliance in your network. Okay. Switches, router, firewalls. Now next is controller. What is VLC controller. So basically, this is the wireless controller. Okay, you might have seen a lot of access points. If I just open up access points, so I'm not talking about those home-based access points. Okay, like your TP links, D links, all those are just a home-based routers or home-based modems, access points. Okay, these are not a enterprise one. For enterprise, we have different access points like this: the Cisco Aeronet or a TP Link, Aruba. So these are the external access point which is used in the enterprises. Okay, so these access point are not kept in one or two. They are sometimes kept in like large numbers, like 10,000s of access point deployed in the whole uh, manufacturing unit. So let's say you deal with some industries. Okay, this industry is into manufacturing. So what happens is, let's say you have a lot of access points. Okay, so you just cannot walk into them. You just cannot go straight away to them and configure them or upgrade the softwares within them, right? That standalone thing is a drawback here. So what we do is we keep a uh, VLC. Okay, so VLC can be on premises, it can be virtual also. That's why I was gonna write VLC. Okay, virtual VLC, which can be hosted on a VM servers, or you can have a physical box that you see on my screen. It's a physical box 2500 series wireless. So what does virtual does is, so you, let's say I have WLC, I have lot of access point all getting controlled on a single point of contact. So like access point 1, 2, 3, 4, 5, and so on. All the access point connected to WLC, and WLC would be the first point of contact to push the softwares, to monitor these access points. So because these are a graphical interface, they're gonna show me that access point 2 is highly utilized. It's gonna show me that there are so many users connected to the access point 1. It's gonna show me that access point is running on so and so version and it needs a upgrade. So I can directly push it from my VLC. It's a controller. Okay, and it's a GUI kind of thing, a graphical thing. It's gonna make me more easier in terms of troubleshooting as well. Okay, so this is called controller. This is access point from the business point of view. Okay, fine. So what next do we see in the networking component? So we have a server. Okay, so I have few more things like server, storage, data centers, and yes, that's for the day would be. So servers, what are servers and what are storage? So let me go with comparison of two things. Okay, server and storage. So basically, server is something where you host your all web pages or applications, right? All your files are stored in a server. So let's say I call sometimes as a Google server. What basically does that mean? It means that there's a server. Okay, there's a server which is controlled by Google, and they have their own web page or application or files within them. So it's more like your files within a server. On the other side, storage is nothing but the storage unit, like your HDD the external hard disk, or your SSD, the latest hard disk that we have, right? We have something called as flash memories. We have those CD-ROMs. We have those floppies. So basically, what were these? They were storage units. Why do we need storage device in enterprise? Okay, so basically, where are you going to take your backups, right? Where are you going to save your backups? So let's say I have my enterprise with thousands of routers, switches, firewalls, WLC, and access point. And on a daily basis, I'm going to keep a copy of the backups, because I may not know, one of the device suddenly just crashes, right? And I just lose every configuration of that. So how am I gonna fix that? So what I do is, the best practice is, keep the running configuration somewhere handy with you on an external storage unit. So we don't use these flash CD-ROMs or all these things. They are a like personal usage. We go with storage servers. We can call it as storage server, but don't confuse with this server. Okay, the work of this server is like web page application file. The storage unit is more like the storing or the capacity that it can accumulate. So we can store all our running configuration inside storage unit. Now, earlier storage unit used to come with the tapes. Okay, there were concept of taking out the tapes, inserting another new tapes. So basically, tapes used to be with some memory like 512 MB or like 1 GB. They are now pretty older, like 10 years old. We used to make use of tape, but now these tapes concept have gone. We make use of SSD or the normal hard disk. Okay, SDD. So SSD is a good one. They are very faster. So let me show you quickly how these servers look like. You might have seen these servers. See, they are the server where you can host applications, you can host web pages, your files, lot of things here. On the other hand, the storage units. So where do you think the YouTube that you upload the videos are gonna store the video content? They need a lot of storage units. Okay, so let me show it for YouTube storage servers. See, these are all the storage unit where the videos are getting stored. So they need the, so it depends on the business point of view. YouTube is more into storing the data, whereas Google or Cisco, they are more into giving the services or a product. It's more about the services, web pages. They don't need more spaces. They need the web pages. They need the servers where they can host the applications, or can give it to the customers. Okay, so depending upon models, we have different uh, units. Okay, these are all uh, the different storage units. Okay, and what you see here is a data center, and within data center you see these rack mounts where you see like a lot of servers, storage unit, the routers, switches, firewalls will be put up. Let me show you the storage server with tapes. See, this used to be the tapes, and they used to like keep like they could use one tape for like 1 week, because backups are very small file in KBs. Depending upon what you're trying to backup, sometimes some company backup the Outlook also. So that's gonna take some memory because of the images or whatever you have within them. So these are all gone now. The latest servers comes with SSD. Okay, the a very good technology. So if you see this, this is your SSD. See, do you read that SSD? So you can place a lot of SSD, and one SSD easily comes like one TB or 2 TB or 3 TB or like 40 TB. So the capacity is very high in SSDs. SSD storage. Then we also use SSD nowadays on the laptops, and especially the C drive, the booting operating system are loaded up on these SSD. That's make your operating system just get rebooted in just seconds, few seconds. If you remember the same instance of Windows 10, if you put up on a SGD, the normal hard disk, it will take at least like few minutes, like 1 minute to 2 minutes. But if you make use of SSD, it's just like 10 seconds, your system gets booted up or gets rebooted. That's how the difference between the storage units are. So we as a network engineer don't deal with server storage. In fact, so we all deal with the routers, switches, firewalls, controllers, and access point. Okay, server has their own team and storage have their own team. We just coordinate with them over some P1 calls. Whenever we get some P1 calls, we interact with them. That's all. We otherwise don't uh, manage those devices. So this is a data center. So someone who doesn't know what is data center, so basically this is a building where the whole devices that we just discussed are gonna be racked. Okay, so if I show you the Facebook data center, see, this is how the data center would look like. You can also see sometimes the 360-degree view. So let me show you that. If I have for Facebook, okay, so it says that there is a Google data center 360-degree tour. Okay, I'm not gonna play that, it's gonna cause disturbance. You can see the lot of Cisco boxes, servers, storage unit. So all big brands like Google, Cisco, uh, Facebook, YouTube, they have their own data center in multiple locations. Okay, they have, like in India, Poland, US, they have their own data centers. So sometimes if you get time, just watch that 360-degree, you're gonna understand what the data center is all about. Okay, so you can see the Facebook data centers, they're in multiple locations, and this is from US point of view. If you talk worldwide, then there are like a lot of data centers. So this was a Google data center, this is a Facebook data center, which is something looking like this from an aerial view. Okay, so that ends your first PPT. Okay, class 1, 2, 3. So basically we covered the presentation from this point of view. And yes, this presentation is already put up on the web portal. So it's over here. And yes, regarding download, might be I have not told you, you cannot download the videos, but you can access it from mobile, or you can access it from the portal directly. You can like make a full screen, because it doesn't matter watching the video. It doesn't matter. It's a good that it's on a web itself, otherwise you will end up downloading and keeping it somewhere, the memory issues, all those things. So they are gonna be online, so don't worry about that. Regards to the PDF, you, in case you don't prefer watching it on a browser, you can just click on this button, the button which says slide share. Okay, and it will let you to download them. So but to download them, you need to have a LinkedIn ID. So if you put your LinkedIn ID, you will automatically get downloaded. And don't worry, the LinkedIn ID is not something which I gonna get to know, or it's not gonna get social or gonna be public that you downloaded something. It's just that you create some LinkedIn or you just create something, LinkedIn profile or something, and you just uh, download them. Okay. Fine. So let's see the Q&A. If you have any doubts with respective to the class or the lab or web portal, so give me heads up so I can let you know. Okay, so I'm going through the chat windows where it says, is there a way to change the second password? Actually, the second password cannot be changed. It's the decoded format of a uh, some word. Okay. Uh, Actually, the thing is how that second password work is, it's a it's a encrypted format of a string. I just made use of some string like network engineers, and that network engineers was encrypted in this pattern. That's why you see that very mess kind of password, which is not easier to remember. But yes, you need to follow this cannot be changed. Yes, you can change your own login password from what I gave you, but you cannot change this is something which you have to copy and paste.
Hi, Sagar.
And
This is
yes,
Navjot.
yes.
Just regarding this web portal, I don't
Okay.
have that email. I joined today,
Okay.
so
Okay, I'll
can you
give you
please
after
send me the
this. Yeah, I'll give you after this class. After the
uh,
class, I'll give you CCNP.
as
Okay.
well as the lab access details?
Okay. Okay.
Thank you.
Okay. So your lab, you have to talk to the lab trainer. Okay.
Okay.
Okay. Sorry, that was not to you. I was just reading the chat. Okay. The next question here is, please take ASA few classes. Okay. Okay. So there's one more question which says that after the course, how long the students gonna have the access? It's a lifetime access. Okay. There's nothing like month or year. It's a lifetime access. Are we going to do some configuration on WLC? Yes, I will show you the WLC GUI interfaces, how we configure all those things. But we will not be able to test because we don't have a physical access point. So WLC works when it has a physical access points. Okay. So on there's no provision of virtual access point so far. But yes, if we have virtual access point some one fine day, we can completely check WLC and getting associated with a virtual access point. But yes, as of now, I can show you the virtual WLC, how it looks, what are the different options you have within WLC controllers. So guys, any doubt? Um,
Yes,
so
yes, so how can I get in contact with the all the lab trainer? Because I'm
okay,
open my my lab
okay,
and
okay.
it's not working. So I don't know.
So what is not working exactly? Because I remember the
Uh,
last day
yeah,
we've fixed it for you.
yeah. It's as soon as I came and put it on today,
Okay.
it started to it came on the VMware and it just stuck.
Okay.
Yeah,
Okay,
because
fine. So yeah, so I will notify the lab trainer. Okay.
okay, all right.
Okay.
Thank you.
Okay. Thank you. So how about the class? Do you think we are fast? Do you think we should slow down? Do you think we went through some difficult topics, or do you think there was any problem understanding something so far?
It was okay.
Okay.
It's just after the class we just have to go and do our own reading
Okay.
through the slideshow and
Yes.
understand for ourselves. Yeah, boy, it was okay.
Okay.
Yeah.
Okay. So basically, this is all the bridging topics which I guess you might be aware of from your CCNA. But yes, the reading is again something which I don't say to stop. You can uh, it's not in your official textbook, so you have to search on Google to get some more details. If you're not if you think that you need to brush up the CCNA basics or something, okay. uh, and the actual topic for the CCNP is all this different components. So we are also touching the CCNP. We are not leaving out the CCNP and just doing the CCNA. We are just trying to have both of them in this bridging session. So we are touching the CCNP first few topics like 1.1, 1.2, 1.3, where it deals with different network components. Okay. All right, guys. So that's all from my side. And if you guys have no further concern, so we will meet up in the next weekend. So that's all from my side. I'll host it on the web portal, and yes, you guys can uh, you guys can watch it later on.